Hi, everybody. I'm Keith Kamholz. I'm an effects lead at DNAG. I've worked at a bunch of other places as well, ILM San Francisco, and Blue Sky, and Tippett, and a couple of commercial places. And I'm also an effects instructor at CGMA. It's an excellent online school for Houdini things and other things. But Houdini stuff's obviously my interest. In the past several years, I've had the pleasure of working on lots of destruction-heavy shows. Personal highlight, Pacific Rim Uprising. It's kind of a bucket list for a destruction nerd. And destruction's very much become my thing. And I'm always excited to share my workflows and tips and tricks. So a few things we're going to focus on in this. Obviously, we can't focus on everything you need to do in a destruction shot. There are so many multiple layers. We're not really going to get into all the secondaries in this. But we're also going to try to focus on new things in Houdini 17 and 17.5, because it really does change a lot about how I approach the general setup process, like fracturing through constraints and post-sim work as well. And let's see, this is a shot from previous version of my destruction class. I know probably looks familiar to some people. And actually, in this shot, I didn't even use constraints for it. This is actually not the final version, but this will suffice for going through the first couple things we're talking about, which will be fracture workflow and working with the new constraints. So when I'm starting with the destruction shot, I always try to get a pretty good idea of what I want the end state to look like. A lot of people will go in and fracture the whole structure into a million little pieces and set up, super dense constraint network and kind of see how it breaks up when something impacts it. But I always try to imagine, based on the animation, exactly what that whole would look like. Oftentimes, when things get destroyed, you see the whole that's left behind a lot better than the actual pieces. Pieces are flying around and motion blurred and etc. And really try to put a lot of care into what that whole looks like. So typically I will carve out the area. And also computing time, our processing power and our personal time are finite resources, so we don't need to waste our precious time and processing on areas we don't need. So in this case, I've carved out just the section that we're dealing with in this particular animation. And in this case, I chopped it up a little bit more than I probably should. Ideally, I would maybe take these spheres that I use to isolate that area. Probably should have converted it to a VDB, and I typically do now. And then you convert it back into polys from VDB, so it'll just more nicely chop out that section, so you don't get all these extra cuts from the very beginning. And whenever we are starting with this process, you can see it's visually broken up into at least a few different sections. I always make sure to store that data at the very beginning of the process, because there are many things that might come in handy for later. Perhaps they want to adjust the sim properties just for this roof portion, or maybe you want to treat the constraints differently on this base here, or something like that. Could be lots of posts and things you do to each section differently as well. So I always store an original name before we start fracturing it. And for the actual fracture process, Houdini 17 introduced the RBD material fracture, which is very cool, but I still prefer to set up my own bespoke workflow for it. For me, it's very important that I can see exactly what the cuts are going to look like before I run the fracture. And with setting up Boolean cutters in a bespoke way, it gives you a very good idea, obviously, straight away what those will look like, rather than waiting on a completely procedural network to run to see a result. I do think the RBD material fracture is very cool for someone that just wants some quick results straight away, or maybe, if you don't have the time or experience to put together a completely bespoke fracture, then it can be very cool. And some of the glass effects are quite cool as well. and the wood. But for concrete, it's pretty easy to generate your own procedural cutters like this. I set up my own cutter geometry HDA, and the way I tackle it in my HDA is using a couple different stages of noise to design those shapes. So first I'll go in with probably fewer cutters than you see here, maybe just a small handful, even just like 5 cutters, just to start dialing in what those shapes look like. And I'll control there's a large scale noise size parameter and an amplitude for that. And that'll just give you the overall shapes. So you can immediately visualize just with that what it'll start looking like. And once you're pretty happy with those shapes, there's another control I use to just add a little bit of extra detail on top of that, to just kind of control just the level of jaggediness of those concrete surfaces. I also, in my tool, add an extra layer of subdivision just before the fine detail process. Because for all of the cutter generation and the low frequency detail, and then trimming it in after that before applying the fine detail, you wouldn't want to necessarily do that on the super maximum density mesh. So I do it halfway through, just before adding detail noise, do an extra subdivision or 2 or 3. And that's control that I expose in the tool as well. And another option that I've added more recently to my cutter geometry tool is the option to add an extra input. Because if you want to go in and perhaps copy the same general look across various other parts of your geometry, it can be really helpful to put your own cutters into this and get the same look coming out the end of the generator. I do this all the time now, because really, when we're fracturing a given scale, once you kind of figure out the noise sizes that work for that scale, it's probably going to be pretty consistent across the whole structure. And with this extra input, it'll just run all the same noise settings. In this particular case, I have my generator set to generate 0 cutters and only use that extra input. And because I do use, in this particular example, a really massive amplitude for the low frequency noise, I've turned that all the way down to 0 as well. So it's just picking up the fine detail to match what we had here. It's a very helpful option to include. And with these sort of things, your workflow will always be, you'll always be updating it as you work. I'm sure you'll probably find some other features that you find very handy that I've never thought of. One optional step just before the output of this cutter generator is whether we trim it down to the actual geometry or not. Now, when running the Boolean fracture, these cutters, as you can see, can get extremely dense, especially if you're doing a Boolean fracture on a large portion of a skyscraper or something. I'm trying to remember the latest scene I was working on. Some millions of polys in my cutters. I can't remember how many millions, but it gets pretty heavy. And that was after I trimmed it to the object. So I can't imagine how many millions it would have been without the trim option. But the reason it's not on by default and it is an option is because, especially when we're not working at really massive skyscraper scales, for example, I remember this popping up when working on a truck, for example, that I was fracturing. You might want to move these cutters around afterwards, and if you have it already trimmed exactly to the geometry, you can't really go in and hand pick cutters and transform those around to really art direct exactly what it looks like. That's why I leave it as an optional step, and also optionally output an ID for each individual plane. Because really, kind of the recurring theme for all of my preferred workflows is like proceduralism mixed with manual work. I know a lot of people really shy away from doing things manually, but it's all those sort of like manual decisions that can really allow you to finally art direct and respond to notes in a studio setting when it's not just up to you. So that's, yeah, very helpful option to have on that generator. And you'll also notice I've got an extra mountain at the very end, because not all the detail has to happen in the SOP. You can absolutely add some extra post-processing if you would like. And then finally, I'll run the shader. And I use my own shader HDA, which is a pretty simple wrapper around the regular Boolean fracture. And one awesome thing about RBD material fracture is that it'll do a per piece loop. The regular Boolean fracture SOP, I wish that had that option. Maybe we'll get it, but at this point we don't have the per piece option in the regular Boolean fracture. So in my own shader HDA, I loop over per piece to fracture each section independently. I also trimmed down the cutters to just each individual piece. It seemed like it goes a whole lot faster, especially if you think of something like a skyscraper with millions of polys stretched across large world space. Maybe a floor of that skyscraper is only using a small subset of that. So in my per piece fracture loop, I trimmed down the cutters to just the portion that we really need. The other nice thing that the Boolean fracture and RBD material fracture updates give us now are automatic piece name handling. Prior to this, it was pretty annoying to use wrangles all the time to kind of always keep track of appending onto our piece names. And some of the, that's one of the most annoying things about destruction work in general, is just like wrangling all that data in a super clean way, because you have to keep track of that stuff or you'll run into problems really fast. And it's not the most exciting part of destruction, but it's very important. But yeah, that's very convenient update in the latest versions of those tools. The other super awesome thing that I love is that it now generates the constraints for us at fracture time. We don't have to muck about with connect adjacent pieces to get just the right amount of constraints generated between them. It does a really good job at just giving you exactly what you need, no more, no less. So to use both of those outputs coming from that, either the Boolean fracture or the Voronoi fracture as well, or the RBD material fracture, I'm sure they all do it, we have to be able to pack them together in a clean way. And the RBD pack node is not probably a headline grabbing Houdini update, but it's extremely helpful, especially when you're working with fracturing and loops and such, because you need to be able to combine your data streams without mixing up all those attributes. If you were to just merge together your fracture with your constraints, then they would all pick up each other's attributes with some sort of default values, and it'd be pretty annoying. We don't really have a clean way to separate that. So our RBD pack allows us to, output those from a loop together in their own separate buckets, and we can cache them together without managing different caches, and etc. So after I cache out my fracture, and I always do cache out the fracture with the constraints before doing all of my optimization, with this smaller example, it's less crucial. You could, do all of your optimization before caching it out. But if you're running on a big building where it's a much slower fracture, then you don't necessarily want to rerun that fracture if you decide that you were overly aggressive with calling out tiny pieces or something like that. So I'd always make sure to cache it first, and then I start to optimize things. And one thing I'll do is remove, like I said, the tiny pieces. You always want to drop in a clean node as well with the unused points option checked on, just to clean up those stray points. But, and I don't have a slide for this, but you really have to watch out for the remove degenerate primitives option, because that's overly aggressive with what it decides to clean up. A lot of times you'll have little slivers of geometry that are totally valid, but it doesn't think that they're, and we'll clean those. And that in particular will really mess you up for refracturing. Any of those little non-watertight holes that might be introduced will break any subsequent Boolean fracture processes. even if you don't really, if it doesn't cause a problem visually, it can certainly cause more problems down the road. So just fair word of warning. And for calling out the tiny pieces, I use my own measure fracture, HDA, which is very simple. HDA just gives you options for calculating per piece area, or volume, or bounding box size. In previous versions of the built-in measure tool, you would have to maybe measure all of the area per prims and loop over those and promote to detail to sum them up and back. And it's really an annoying extra loop just to get the per piece overall surface area or volume. This is another thing I don't have a slide for, but the new measure is really awesome because it's got this per piece attribute option on there, and it'll automatically accumulate for each individual fracture piece your area or volume or whatever. But that said, I usually use bounding box size anyway, partly because it's just faster to compute, because all you have to do is multiply your x, y, and z sizes. And it also works on packed or unpacked geometry, so you don't have to really care what your input is with that, whereas with area and volume, it has to be unpacked geometry. But what's really helpful just in using my own version of the tool is that I have my own splitting option built in, so you can choose which attribute you want to filter by and give it a threshold. This is something that I will do. Sorry about that. Where was it? Yes, so the measure fracture HDA. Throughout the course of doing a destruction shot, whether it's the RBD setup or post-processing or secondaries or whatever, I'll be splitting out things based on size so many times. So if you do it by hand, it'll be a lot more work than if you just create a simple little HDA for doing your size splits. I prefer to set it up so that the first output is the small pieces and the second is the big ones, so that when you display that HDA, you can see exactly what you're calling, but then by connecting the second output, you can continue on with just the big ones. And really, that can be a pretty profound impact on the number of pieces in your simulation. Even if you're not concerned about optimization in terms of processing power, sometimes really teeny tiny pieces in a bullet sim will behave oddly, even if you really don't care about particulate scale pieces being in your sim. I wouldn't trust the behavior of those. But anyway, after we clean that up, we have to also update our constraints. I'm just doing this in a per primitive loop, not by name or anything, just each individual primitive, and checking point 0 and point 1 against our fracture pieces to see if the name exists in the fracture. If either of those no longer exist, it removes the prim. This would probably be a good one to compile, since it's running on every single primitive in our constraint network. But since it's only running on a static frame, it really wasn't that bad non-compiled. And the last step of our fracture optimization process is the convex decompose. And if SideFX added nothing else in Houdini 17 aside from convex decompose, I would have been happy. In the past, I've not even bothered creating proxies most of the time because it's just such a pain to build something that's a good representation of your geometry. There are various techniques that existed, prior to having this tool that would kind of do it, but even in studio environments, the tools available were not that great. And this is, it can get slow for doing it on a skyscraper level of fracturing, but it is really quite fast and gives us really nice, clean results. And excellent proxies to work with in our simulation and post-processing. So once we generate those, we can hook it back into our RBD pack and that third input and cache out that nice little sim-ready bundle. For deforming objects, it's a similar situation, but slightly different. This is an example from my new destruction class that's just starting up. And for deforming objects, we obviously, maybe not obviously, but we don't want to run that convex decompose every frame. Not only is that super slow, you need to have nice static geometry going into your sim as a collider. So we'll just do the convex decompose on a rest pose. If you have rest data, that's great. Otherwise, just pick a frame where he's not intersecting with himself, run your convex decompose on that guy, and you can point deform it with his original mesh. You'll notice that I left out some of his various horns and things, just because you don't have to feel like you need to include everything. Any little bits of optimization that we can do along the way will all add up throughout the whole process. And I just know based on his animation, these horns over here will never collide with anything. So it's good to just remove anything that you don't think you will need. And like I said, like the RBD pack is not the most headline-grabbing SOP that was introduced. But just from a learning standpoint, I think it also really helps people to compartmentalize each step of the destruction process. If you do all of your fracturing and constraint work and sims and massive networks, if you're really new to Houdini things, it can be a bit extensive and intimidating or hard for other people to understand. So by cashing out these little bundles of rigged up sim elements, we can divide it up into various processing. Like in this case, I've got my fracture in one section, I've got the constraints between sections done elsewhere, and clumping, and then simulation. And each of those is nicely manageable. So, I don't expect you to be able to read this from where you are, but the bottom left is generating constraints between sections, which allows us to use just this nice little concise network for doing that. Now, I mentioned that the fracture process will give us our constraints between all the fractured pieces, which is really awesome and convenient, but it doesn't give us constraints between pieces that are fractured separately. And there are different ways you could create your constraints between those sections. In this case, I felt that when I set up this little network, it was more on like a skyscraper level scenario. So I used a detail wrangle. So I looped over all the points in the fracture and just used a PG find lookup to find any other points within a given area. And if that original name is different than the point we're looking it up from, then we'll just create a constraint primitive and vex between them. If you don't want to mess around with detail wrangles, you could probably do something else. Like I've done silly things in the past where I would maybe just generate constraints between all sorts of things, and then just after constraining everything, go through and process them all afterwards to figure out if they're between sections in this case, or whatever else I might have been doing at the time. So yes. Yeah, after we've got all of our constraints between sections set up, a big part of the art direction process is creating clumps of those constraints, or glue islands. Now, with this skyscraper example here, you can see it's kind of broken up into tons of tiny little pieces. And let's say maybe this case, maybe the building's exploding. You wouldn't necessarily expect it to be into a million little pieces. You want to see some nice big chunks. And that's one of the focal points, especially like from a supervisor or a director standpoint. They really want to see these big, large-scale pieces, mixing it all up. And that's one of those things that you can expect to get lots of notes on. And I've seen lots of setups where people use maybe noise patterns to set up groups of constraint clumps. And that can work fine, but I much prefer to do it with geometry grouping. And like I was saying earlier, so many of my processes are really combining manual and procedural techniques. So when you're using geometry grouping, that allows you to exactly specify where your clumps are going to be. Like in this case, they might say they want that corner of the building intact, and maybe as a story point, they want this piece on the side exactly right there, because that needs to fall down in the next shot and crush something. But we don't want to do everything manually, of course. So I will typically use the same general technique and just scatter some spheres throughout the building. And another SOP that probably isn't one of the headline-grabbing SOPs that I really love is the new attribute noise. It just saves a lot of work of just going into VOPs and creating your noise and adding it to the position every time. It's much more convenient to just use our attribute noise now, which I'm using to just distort the sphere positions. And then once we have both our procedural noise groupers and our manually placed ones, I will run a loop over all the geometry, and it'll be a loop with feedback. So every iteration of that loop grabs one of those distorted spheres, whether it's manual or procedural one. And it'll group that geometry and tag it with some sort of a clump number. And then as that for each runs again, with the feedback turned on, it'll maintain that data, and it does it for every single sphere. So by the end, we have our grouped geometry with a clump value for each section of our RBDs. Now, I do this on the fracture geometry because I like having the visual feedback of what those clumps look like. But you could just do it on the constraint geometry directly if you prefer for some reason. But ultimately, we want to keep track of the same data on our fracture, constraints, and our convex decomposed proxies. And if you have to manually, every time you do something of interest in your network, copy the data to all three, that would be a real pain. But thankfully, we don't have to worry about that with our clustering information here. Because if you just copy those clump numbers to your constraints, and then run that into the RBD cluster SOP, and pipe in your fracture and your proxies, of course, it'll automatically populate those clump IDs to your fracture and proxies as well. So it's nice that they handle that for you and you don't have to do it manually. And also, I do use these clump attributes for more than just constraint grouping. Sometimes I will do the same process, and then I'll maybe even just throw away that group of constraints and say that I want this piece to be hand animated in the shot or to be activated later in the shot or something like that. So yeah, this sort of grouping situation is not only for creating these glue islands. And once you run your RBD cluster SOP here, that will, I'm pretty sure it's the default option, generate groups for all of your constraints, determining whether they're just within a given clump or between clumps or clumps to piece or between disconnected pieces. And that's all very helpful information when you set up your simulation. Because in your constraint properties SOP, you can just grab any one of those groups. So in this case, I might set an infinite strength for the intra-cluster group so that these interesting pieces that have been designed always remain such. Maybe I would have any other pieces connected to that each of those glue islands to have an extremely small strength so that it doesn't have a tendency to grab extra pieces onto it, and so on and so forth. You can art direct that to your heart's content. Another option just with the clustering, there is an option to change the names of the geometry, which is, I see this as more of a fracture time process where you can, if you have that clump or cluster attribute, I should say. I keep calling them clumps, but cluster is probably more familiar. You can also just change the names of your geometry so that each of these design pieces, the raw polys do get a different name attribute reflecting that, and you can pack them up that way so that it's actually just one object. And when you do use that form of clustering, where you're just changing the name attribute, so each of those chunks is a consistent name, by default, that will still just create one convex hull around everything in Bullet. You have to use the create convex hull per set of connected primitives option, and a little verbose, in the RBD packed object, and it'll still create different convex hulls for each of those sub pieces if you turn that option on. You can also override that on a per piece basis if you want to with the bullet group connected option. Doing timer, I think we're all right. So yes, this is a shot I've been working on. This is not in a finished state here for my new destruction class. And this has had the RBD sim run on it, obviously, but it's also had post-sim tweaks applied to it. And I have people ask me all the time, what sort of things can I focus on to, really like give me a leg up as a destruction artist or something. And like I've alluded to a few times over, any sort of like manual things you can do makes a huge difference. I know I've done some shots where it was practically glorified effects shot sculpt, but it just, some of the most beautiful shots I've worked on have been just like hand animating things essentially. Which sounds like, you might say, oh, that shouldn't be an effects task, but a lot of times coming to that from an effects standpoint makes a huge difference. Perhaps I might, use different noise patterns to sculpt something and then put some sine waves on bend deformers for wiggling things. And you'd have good judgment to know where and which parts you want to use more of like a shot sculpt technique versus more of a proper simulation technique. And you can make that decision better than someone else deciding who should do the shot. And that particular shot here that we were just looking at, I'll just walk through some of those post-sim tweaks. And one of the first things we have to do with these type of shots before doing any of those post-sim tweaks is figure out what the active frame is for each of those objects. Sometimes I'll set this up pre-simulation where I'll specify an active frame attribute on the pieces and then trigger those in the sim to become active. But when everything's constrained together, you don't have that information for free. So after I cache out the points, because you always want to cache out just a point for each RBD, you don't want to cache out the raw geometry, I'll run a SOP solver to determine when they start moving. And then I'll store that as an active frame attribute. And if a piece never becomes activated, I will typically treat that separately, but I'll often copy over the active frame from whatever its nearest piece is, so that for the stuff that never moves, you know when its neighbors have started moving, which can be really helpful for some of these other tweaks. Before I talk about those other ones, though, one quick tweak that can save you a lot of sim iterations is simply to fix popping with a blend shape. You can blend shape just the cache simulation points themselves, and it's always good to investigate things when you can, but it's often not worth resimming your shot to figure out why a few pieces or clumps pop here and there. And my little shortcut that I always like to use to animate lots of parameters, whether it's a blend shape or smoke solver, turbulence or something, is to use a fit function on the frame rather than mess about with keyframes, because it's annoying to keyframe everything. You can just use a fit function on the frame and then give it a start and end value for your animation and the values you want it to return. But yeah, so back to the actual post tweaks on the static section that I was starting to mention. I do a lot of this sort of thing where for the static pieces that never start moving, I'll add a lot of crack detail, maybe just by randomly rotating all the pieces. And you don't want it to start out like this, of course. You'll want to use the data for when the nearest neighbor starts moving to blend it on over the course of, however many frames you think makes sense. Maybe it blended on over 10 frames from when its neighbor starts moving. I also do a lot of things like sagging floors and such. In this case, it's using a combination of attribute transfers from the walls to figure out how far it is from the wall. And once again, neighbor active frame stuff to figure out when it should start sagging. And all of those sort of extra little tweaks can really break up what looks like otherwise a pretty basic RBD sim. Because you do often see that with just standard RBD sims where things get knocked all over the place and then you just have these perfectly intact holes. And anytime you can break that up, it's going to be very helpful. In this case, I also did a little soft transform on the roof. This is something where I would have loved to do this with the new soft constraints, which are excellent, but sometimes you just don't have the time. And for the sake of a couple soft transforms, it's often more worth doing that than doing a full soft constraint setup if you don't have the time for it. But once we do all of these post-sim tweaks, it's still very helpful to have all of those kind of SOP level manipulations applied back to the points. And before Houdini 17, that would have been a much bigger problem. But now we have the extract transform SOP, which I absolutely love, because all we have to do is pipe in our moving pieces and a rest state for those pieces, and it'll export points that you can reattach all your geometry to. So even though we're doing all of this extra custom, SOP level manipulation, it's still ultimately passed on to the raw points. And not only is this much more efficient, if you are working on things in different ways, it can become more complicated later in your scene. For example, when you're doing your secondaries or attaching rebar or etc., you might have different types of input if it's all, raw simulation versus manually tweaked or whatever. So to have sort of consistent input to all of your later processes is very helpful. And this is not the prettiest example, but once you have those points via the extract transform SOP, you can easily attach things to them just by scattering extra geometry and giving it a name that matches the piece. So in this particular case, these pieces of rebar have a name attribute that matches the piece name they're attached to, and they can just use transform pieces the same way that all of your fracture pieces do. It's just a very, very easy way to attach them. It's far better than point deform, especially like in the case of a point deform, if you have pieces that are touching each other and then they separate later, it will get very confused about what it should actually be attached to, and it's slower because it's actually calculating a lot more. But anytime you can attach things with transform pieces instead, it'll be much better. And this is a closer to finished version of that shot from a new class. And destruction really just comes down to layering, and this is coming along pretty well, but it still needs, in my opinion, more debris layers and such than it has here, and more layers and the window effects and etc. But this has a lot of those post-sim tweaks we were talking about with the cracked walls, sagged floors, rebar, etc. And all of that stuff goes a long way toward just enriching the visual complexity of the shot. But yeah, hopefully that was all interesting stuff for you. And yeah, happy to answer any questions if you have them.
Any questions for Keith?
Hey, thanks for a great talk. I have a question. Do you use any of the 17.5 new features where you can paint the constraints?
I haven't used them yet. And to be honest, like in a studio environment, we often lag a little bit behind the versions that came out yesterday. But that's a very cool feature when you get into more manual things. Most of the time, I try to do my constraint stuff procedurally, but yeah, I don't expect to use it super often, but I think that when I do need it, it'll be very helpful to be able to paint that, yeah.
Thanks.
Anybody else? Yeah.
Hi, thanks for the great talk. I was wondering about UVs. How do they fit in? When do you create them, and how they go through the whole system?
That's a good question. I mean, as effects artists, I hope that the UVs would be on the object before we get them, and you always want to make sure that data is kept intact. And like I mentioned toward the beginning, some of the less exciting stuff about destruction is just maintaining data, but it's incredibly important, both that you maintain things like that that are vital later on in the workflow, and also that you don't maintain things you don't want. I've seen fracture times go like absolutely through the roof because assets will come in with tons of unnecessary attributes. And anytime you run a fracture, it's interpolating all the attributes on the geometry to figure out, at all those fracture points what the values should be. So yeah, you have to make sure to get rid of stuff you don't need and vice versa. But for all the inside faces, ideally, well, I always make sure to add rest data to the geometry when it's fractured. And if we can use the rest data for shading it, that's great. In my experience, usually the look dev guys are good with that. But I also, it does vary per show. And one of the other steps on my cutter generator that is an optional step is adding UVs to all of the cutters themselves. So if you add decent UVs to all of those, then that will be inherited by all of those cuts, and that can be helpful later on in the process. Sometimes I put them in different UDIMs as well. And that's another reason that it's super important to only cache out the per piece points from your RBD sim and to not just cache out the geometry, because when you've got all the points, you can massage the data all you want to later. And this project that I have the thumbnail here for is a good example of that. So I was working with a lighter who was working in Maya and V-Ray, and he was having all sorts of problems with getting shaders applied, so I was doing all sorts of hacky things to, give him access to like inside faces and things in ways that he could work with it. So it's very helpful to be able to just modify your fracture stuff and have it cleanly reattach.
Anyone else? Hi, thanks for the talk. Do you guys do anything to make sure the renderer sees all the information it needs in case it's not Mantra? Some metadata on the exports, some vertex, some channels on the vertices, and so on, to make it easier to do things that are shader sensitive on the render, basically for the shaders to be able to use data that's on the simulation.
Yeah, most of the time it's good. We kind of know what things we need to preserve. We have our custom rest attributes that are common, like all the obvious things like UVs and whatnot. Sometimes they insist that whatever the asset comes in with, we have to pass it through, but like I said, it can be an absolute mess for fracture time, so I often just get rid of that data unless somebody complains. But as far as, like adding extra things, it's kind of a case-by-case situation where, like, I was working on a show not too long ago where they hadn't asked for it before, but all the inside faces and the sequence they wanted to put into separate UDIMs so that they could work with it that way. So yeah, really it's just case by case. If they want something special, we can do it. But sometimes I've even done effects renders of our own reveal mats and things like that. So
yeah, that's something else I wanted to ask about. If you are using displacement after the fragmentation happens, some kind of an animated displacement, and if you are doing that or the lighting guys are.
To be honest, like, we're kind of insulated from exactly what they're doing often. I think they usually get away with more basic bump and such. I don't think they usually bother with displacement on the inside faces. Like I said, it does vary depending on situations, but yeah, generally I don't think they bother. And also, that's kind of a good point because a lot of people will maybe go with the lowest fracture and say, oh, we can like add detail later. But when you're showing things in dailies, you're always showing your own effects renders without all of this extra shader stuff going onto it. And you have to, sell your shot, not just sort of pretend like, I promise the inside faces will look better, when someone touches them. So I tend to put in extra.
Do you try to cover them with secondaries, with dump particles, something like that?
Yeah, that's, this sort of thumbnail frame is a good example of that. I always tell people not to spend, too much time making sure everything's perfect because so much does get covered up. And I didn't, like I mentioned, pop fixing and post-sim tweaks. In this particular shot, there is a pretty bad pop that I didn't bother fixing because I was pretty confident that the dust would hide it, and it does. But yeah, sorry if I derailed from your question exactly.
No, that's good.
Yeah,
Thanks.
yeah.
Thanks a lot.
Anyone else over there?
Hello. How do you handle small-scale destruction when you have like close-ups with a lot of really small pieces? Is it just as simple as scaling up everything before the sim, or are there any other tricks?
I think I'm less dogmatic about scene scale than most people. If it's a really tiny scale, then yeah, I would absolutely scale it up. If it's very small and Houdini units, but generally speaking, if it's not unreasonable and seems to behave well, I'm usually not very strict about that sort of thing, because as soon as we start like art directing the sim and getting notes, like real physics tends to go out the window pretty fast. So I'm not, not very dogmatic about it. Just if it's something extreme, then I'll shrink it or enlarge it. But
all right, thanks.
Yeah.
Anyone else? Going once, going twice. Okay. Thanks, Keith.
Yeah. No, thank you. And small little half lie on the email list sign up. It's not on the website yet. I haven't linked it up yet. It'll be up on the website like later this weekend, I'm sure. And I'll probably post the direct link to sign up for the email list on my LinkedIn or something in the next day or so.
And you touched on your course that you're giving that's upcoming,
Yes.
but do you want to maybe talk about that just for a minute?
Yeah, this thumbnail image is from the new version of the destruction class, and there's a new session starting up on Monday. And it's an 8-week class on CGMA, and it goes through the whole fracturing process in great detail all the way through sim, post-sim tweaks, special window handling, because windows are another beast we didn't get into whatsoever here, where I do completely different solutions to handle windows in different layers. Yes, debris, dust, etc. More than we can fit into a session like this. But yeah, for anyone interested, definitely check out CGMA for that in-depth class.
Awesome. Thanks again.
Thanks for reminding me. Thank you, guys.